Hi, this is Rajasekhar and my teammate is Shamitha. I'm going to discuss about the Twitter clone part 2 using WebSockets, which we implemented. In part 1, we implemented Twitter clone using the Erlang, just the Erlang message passing, in which we don't have limit on how many number of messages we are sending between the actors. So at there, we just send the messages and we will just receive them back. Servers will send them back, and the basically the client will show the messages accordingly. But in the second part, we have implemented it using the WebSocket interface, which we have the GenTCP in Erlang, in which case we can just send and receive only two things. One is the socket and the socket connection, and the second one is the message which are going to send. So while sending this message, we'll encode it into a JSON format and we'll send it, and we'll do the same from the other end as well. But server receives the JSON part, it will decode it, and it will run the operations which are it to do. It will process the data, and it will encode the data into the JSON format, and it will send back to the client again, and client will show the corresponding request by the user in his current window. So we implemented this in two parts. One is the server module and the client module. Server module will handle all the requests made by the client, registering the account, logging in, logging out, retweeting, querying. Everything will be done in the server, and just client just requests it, server will process it, and it will send back. So for this to happen, we need to have a database where we need to store whole data of whatever, who the user is having, what is he tweeting and all. So we have used the ETS database, which is available in Erlang. It is very efficient, and it is very easy to use it, and it has all the insertion, deletion, and every other functionalities. So and it supports the concurrency well as well. It's like if multiple kinds are requesting to access the data, it will support it. There will be no crashes or anything. So that's why we use ETS. Now let's start by compiling the server and client module. First, we need to start the Erlang. Now compile server and compile the client module. Now, first we need to start the server, because the server will start and creates all the required databases, and the GenTCP, this WebSocket connection will be established. So we'll start the server is to start. So the Twitter engine is started. Now we'll go to the other terminals, which will act like clients, that is the users. So as we already compile the client, we can just start the client. Client is to start. We start a client. So the server has received the request, and it replied, and the stable connection is established to WebSocket. Here also we are using the same thing. We are connected to the WebSocket, and we have various options here. So we'll do the same here as well. Server has replied, and we'll get the same whatever it is. So we'll choose the options here. We'll go to the register. So we'll just register a name called Raja. So username Raja has been registered. The same will be reflected here in the JSON format. The server will print the data. And here we will register another user, Shamitha. So the same thing will happen. Now and the connection is established, and we have registered a user. We can just log in to whatever we have registered. I have given the name Raja, signed in successful, and same thing here. So it's logged in successfully. So now the connection is established, and both the users are connected to the server, and their data is stored in the ETS, the database which we declared. So now we will go to tweeting. We'll just start by subscribe. So it will ask which user to accept. There is one other user, so I will say Shamitha. So now I have subscribed to Shamitha, and it will even print the JSON format. You are subscribed to the user, and there are no errors received because the Shamitha user is there, and the corresponding things will be printed in the server as well. Who requested what, and who requested Raja to be subscribed, and everything. So now Raja is subscribed to Shamitha. So let's start a tweet in Shamitha's client. So now she will tweet with the hashtag Dosp, and I'm even tagging the username Raja. So the server, it will be sent to the server, and that server will distribute the tweet to everyone, and you can see the tweet is popping up here in the live terminal. So whatever the Shamitha tweets, we can see it here. Hashtag first tweet. It will pop up here because Raja subscribed Shamitha. Now you can see the other options that are available here. Now we can retweet the tweet which sent by Shamitha. Username Shamitha is in the list. So which tweet we need to retweet. We can give the same tweet which we kept here. Hashtag first tweet. So it will it will request the server to do that. It will show that Raja is retweeting something and we have retweeted it, and it will be sent. Now we'll go to the option query. Raja, as Shamitha mentioned Raja, we can use the query option here. It will ask my mentions, hashtag and subscribe user tweets. First we'll check for my mentions. As Shamitha mentioned it before, it will be showed in the live terminal, and the same thing will be shown here as well in the JSON format. And we will see the other options we have in the query. We'll see the hashtag. Earlier we have used the first tweet hashtag. We will just type that. We'll get as Shamitha has given this hashtag first tweet, we can use that. And it will be shown in this live chat window. And at last, we can see the query option, and we can use the subscribed user tweets. And Raja is subscribed to Shamitha. It will show whatever the tweets she posted. So number of tweets is 3. So, and at last the option is the logout. If we type the logout, the user will be logged out. And if you want to log in, we can log in. We can type Raja. It will show signed in successfully. And here we have implemented using this TCP send, where at each and every location we will convert it into the JSON format, and we will send it to the server. And server will always be in this command will make the server to be in an infinite listening state, because server should always listen to the request how many our clients made. So it will make sure that it will be always in the listening state. And as I have said earlier, we can just send the socket connection is successful or not, and the corresponding data in the JSON format. We will split the data and we'll match it with whatever request the client made. The register, it will execute the commands in here. I mean, if you have any followers or tweets, it will update the ETS table, the followers and the tweets, whichever are there. And it will send back the user has been registered, whatever errors. If there are any errors, it will send those errors as well. And it will print that in the JSON format. And if there is any, the request is, the JSON format contains the tweet, it will execute all the commands, and it will send the tweets to all of its subscribers, and it will, this Gen TCP send makes sure that the WebSocket connection makes sure that it will be sent to all the subscribers, and it will show in the live window. And the retweet option will be the same as well. And when it comes to querying, we'll see the querying part. We have 3 options. Option 1 to search for your mentions, and search by hashtag, and the third one is search by username. And mention and searching by mention and hashtag, it will use the same functionality. We just need to match a word. I mean, starting with the hashtag or at the rate. We'll use the same function to do the both of the things. We'll just change the word which need to be found, and we'll look up in this is what I told. ETS will support us to do a easy lookup, and it can be happen in parallel as well. Like two clients request the same, parallelly request the hashtags, it will parallelly do that, and we can access the ETS database parallelly. There will be no errors or anything. So we'll look up and we will match the tweet, and we will filter those tweets, and we'll send it back to the server in the JSON format here. Here we'll send that the socket connection, which we are sending the client connection, client WebSocket, and we'll send the tweets, whatever tweets we have received, we'll append them in a JSON format, and we'll send them back. And as the client will always be in the infinite listening state, as a, as soon as it receives the data, it will print the data. The server has replied something, it will print the data, and it will be in the loop again. So it will start to listen again. If the client send some other client asks something, it will receive the corresponding data, and it will print it, and it will go to the listening state. And if sometimes any error is occurred, or if you close the day, if you close the connection, or if you log out, it will send a closed atom called closed, and the socket connection will be closed. So that's how we have implemented. Thank you.